Ryan, I'm back.
Hello.
You moved to Philly.
I did.
You like it?
So far it's been moderate. Yeah.
How long have you been there? Takes a while to get adjusted to city life, I guess.
It's like six months or so. Yeah. It's been interesting. It's been a good change of pace.
Good for you. Everybody should live in a city, at least for a couple of years, I think, a big city. It just makes you understand people in a different way, I think, for good and for worse.
Yeah. It's a great way to say it.
Yeah. Yeah. I lived in New York for, gosh, almost 15 years. So
Nice.
yep, I told you I had to repeat the whole thing because I just knew it would like fall on more fertile ground now instead of bouncing off a harder head. But it's been fun to repeat the class. My daughter's on too.
Nice. Okay, I think we have a bit of a quorum here. I'm seeing about like 14, 15 folks. So I think I can get started. If we want me to wait longer, I can do that. But I think this is about where we got started yesterday, about this many folks. So, okay. Share screen here. And then, or actually, wait a second. Before I do that, I've got to, oh no, it already did that. Excellent. Okay. Still figuring out Zoom, still getting all that stuff to work quite right. Okay. Today, we're going to be talking about HTTP. So remember yesterday, we talked about networking, and we sent messages sort of to ourselves locally on our computer with Netcat. We talked about protocols. We talked about how you send data to a system so that it can understand that data you sent it. And then we sent some messages to a server I wrote online. We did things like asked like, what's your favorite car, and other things like that. And we're able to get the server to give us answers back in sort of a format we were able to understand. We had a shared protocol. And today, we're going to be talking about a real protocol, not just like a protocol that I made up, like something that's actually real, it's actually used. And we're going to do some demos today showing how we'd use that and how a web browser actually communicates with external systems. So this should be a fun day. So this protocol we're going to talk about is called HTTP, the Hypertext Transfer Protocol. That's what it stands for. But it's a protocol at the end of the day. And just like yesterday, it's built on top of TCP. So like you make a TCP connection between a client and a server, and that client and the server communicate over that tunnel or that socket. Really, though, the protocol we're going to be talking about today is just a different format, different way of structuring that data in that connection. HTTP originally was built for web browsers. So back when the web was in its infancy, HTTP kind of was like the thing, the language that web browsers originally spoke and still do speak. And if you're going to be working on the web as a web developer, knowing about HTTP, knowing about how web browsers communicate is really important to be able to work effectively on the web. Like if you don't know a decent amount about it, it's like not being able to speak in the day-to-day world. It makes your life a lot harder. Lastly, I wanted to say that HTTP uses port 80. So we talked about yesterday how different protocols have different standardized ports. Yesterday, our protocol, we were doing it over port 4000. But HTTP, the standard port that all HTTP traffic goes over, is 80. So what happens is, like, when you make a connection, that 80 port is what's used. That's sort of the channel that's the standard one. You can override it. You can say, I actually would prefer this to go over a different port, but if you don't specify it, by default, it goes over port 80. So just like yesterday, HTTP is a protocol that involves two different systems, a client and a server. The client in this case is the web browser or the thing that's actually going to be like initiating the communication. That's usually like a web browser on a phone or on a computer or something like that. The server is the other piece. And the server is what's going to receive the incoming messages from the client, what we call requests. And the server is going to be the thing that is probably running like behind the scenes on a server somewhere in a data center that's actually like processing the requests you're sending it and giving back responses. So those are kind of like the two parties involved in this protocol. So let's quickly go through, like at a high level, what happens in HTTP. And this should seem somewhat familiar to what we did yesterday. In essence, it's the same kind of workflow. So you have the two parties, a client and a server, and they're both computers. They're both connected to the internet. So what happens to start the protocol, to sort of start the exchange, is the client connects the server. It forms a TCP socket from this client to the server. On that TCP connection, the client will then send a bunch of information to the server. That's the request. The server will then process that information, do a bunch of different things, like maybe it'll store in a database, do some math, could even make another HTTP request again to something else. But it effectively does some computations and determines the result that the client would like to get back based on the request. And then once that's done, that result is sent back to the client in a response. Those two terms, request and response, sort of the standardized terms to refer to like each of those arrows. So the request is like the top arrow, the response is the bottom arrow. Request always goes client to server, response always goes from server to client. Okay, so that's like the really high level details, but let's actually see an HTTP request. Let me show you what this looks like. Okay, now this is something I'd like if you all could do along with me. I'm going to maybe do it to start with, but I'd love if you all could give it a try as well. So we're going to use our friend Netcat again. It's going to come up a bit today as well as from yesterday. What we're going to do, though, is you notice this is kind of similar to what we did yesterday. Like there's this NC-L80 thing on the right. That's the server. And then on the left is the client. We've still got a client. But importantly, the client is no longer Netcat. The client's actually going to be my web browser. Oh, I didn't notice. Natasha, you asked a question in the chat. So the client takes the information to the server from the web page itself. The server sends back the information from in the response. For page. And we're going to actually show you this in a second, which might help congeal things a bit more. But I think you have the right idea. Yeah. Oh, Doug, you already answered. Excellent. Cool. Okay, so let's do this little demo here. So I'm going to open up the terminal again. Okay, so I've got my terminal. Now, in my terminal, I'm going to start the server. So I'm going to type sudo nc-l80. Now, there's two things that are different in this command from what we typed yesterday. The first one's probably pretty obvious. The port's different. And it's just because 80, the HTTP port, we're going to use that standardized port. But the other new thing is there's this command sudo at the beginning. What this is doing is not all that important, but just like a high level to maybe give you a base understanding. In order to listen on ports under 1024, I mentioned yesterday those are like reserved ports that all have their own protocols pre-assigned. You have to be in a special mode in order to do that. You have to be what's called root. And this is kind of a slightly more technical thing and something that is, I might be freezing. Okay. Oh gosh. But this root thing is like a more technical mode that's not all that's that you need to be in.
With me, I'm on the highway and there's like rain and storms,
Ah,
and
okay.
I'm just using cell phone. So yeah,
I
it's
got
a
it.
whole.
Makes sense. But you have to be in the special root mode to be able to listen to a port under 1024. So when you hit enter, it's going to ask you for your password though, in order to do this. This is what the sudo thing requires. If you use sudo, you got to enter your password in order for you to give it the special permissions so it can listen on that small port. Now I'm going to type my password, but as I type it in, the characters aren't actually going to show up. It's sort of going to be like invisible. That's totally fine. You just want to type it in and then hit enter once you're done. And if you type it in successfully, then it'll just sort of like be good. It'll run the command. Everything will be great. If you don't have the right password, it'll just say like you have the wrong password, try again. And it's a password you use to log into your computer, just to clarify that as well. Okay. So I've got this running. I've got this nc-l command running here down in a terminal. Now, in my web browser, I'm going to go to this http://localhost:80. So I'm going to open up a new tab. I'm going to paste that and I'm going to hit enter. And what's going to happen is it's just going to kind of hang. It's going to be it's just going to look kind of like it's broken. And that's what you want. We're going to talk about why that is in a second, but that's what you want. And if I go back to the terminal, you'll see now there's actually a bunch of text in here. This is an HTTP request. This is what we're going to be talking about today. So what happened here, effectively, is if you think of the web browser as something similar to the client, the netcat client we had yesterday.
I'm sorry, how did you get it to the page? I'm sorry, I think my screen froze or something. I didn't.
So in order to make this show up, in the web browser, I went to http://localhost:80. Which is right here on the slide. So once I did that, it made all this show up. And the reason why is you can think of the web browser as something similar like the netcat client we had yesterday. So the web browser is sort of like connecting to the server and then typing all this text in an automated fashion really fast and sending it over to the server. So this is like the equivalent of like the FAV sort of question that we sent yesterday. This is the protocol HTTP we're going to be talking about today. So that's the demo. And it's going to be kind of just be like loading in this tab, and that's like fine. You can just close it. But that's what I wanted to show you all. So I'd love if you give that a shot on your own. Have folks by chance already tried it, or you want me to give you a little bit of time to give it a shot?
Ryan, I've already
Hi.
tried it, but I got a usage :NC after I inputted my password. Is that normal? Of
It
course.
shouldn't be normal. Let's do this. Can you share your screen? Let's take a look.
So once I enter correctly.
Yeah, so it's NC-L, not -1.
Thank you.
Yep. No problem.
Oh.
Oh, yes, I'll reshare the slides here.
Ryan, mine's is saying can't reach the site.
Let's take a look. Can you share your screen?
Yep. I'm gonna drag. Excuse me. So I'll try to put the post in here.
And did you run the command in the terminal first? Yeah. Looks like you also did NC-1. So you need to do NC-L.
Okay. All righty.
Yep,
Thank you.
for sure. Let me know if that works.
Hi, I got a message that said port range not valid.
Ooh, interesting. Let's take a look. Can you share your screen?
Okay. Do I need to make it bigger?
No, I can see it. So it
Okay.
looks like the issue might be that you have -L. You want it to just be -L with no space in between.
Oh, no space in between.
So if you hit the up arrow and you sort of arrow key over, you can remove that space. Oh, you're gonna have to arrow key over, you can't click.
Oh.
Um,
Oh,
as a tip for folks, when you have that little square box, the cursor is sort of at the front edge of the box, not the back edge of the box.
I'm just gonna write it over. If that's okay.
Yeah, that's okay. You can't
Oh.
select it though. You gotta, if you hit Control C, it'll give you your prompt back.
Oh.
That might be easiest. Yeah, there we go.
I am supposed to put a space in between the NC and the dash, right?
Yep, sudo
Oh, okay.
space NC space -L space 80. Cool. So now if you refresh your web browser, you should see, yeah, looks like you got some stuff over there in your terminal.
Okay. Okay, I see it now. Thank you.
Yep. And I get some thumbs up reactions if folks have had success. I just want to make sure that generally it's going well. Okay. Yeah, I'm seeing some thumbs up. Excellent. Okay.
It won't let me put my password and
So when you see that prompt, you start typing, you're not actually going to see the characters of what you're typing, and that's totally fine. Type it in as though you're not seeing the characters, just like hit all the right keys and hit enter, and that should work.
okay, thank you.
Yep, it's a little weird, but it's just sort of how it works. And if you type the wrong thing, if you like hold backspace for like a few seconds, it'll just clear out the whole thing for you. That's a good trick. Okay, so this is an HTTP request. This is kind of what we're looking at here. And for everybody, each person might look a little bit different. Like you might have some slightly different formatting, but generally the structure should be the same. So we're going to walk through bit by bit and explain what each of these things mean. Okay, so the first thing you're going to see in your request, the first word, is what's called the method. And this is going to be a word like get, post, put, pass, delete, and there's a few others too. All of your requests are going to say get at the beginning. Think of this kind of like the verb of the request. It's like what you're trying to do. Get as a verb in HTTP lingo means like read or like access, or I would like to fetch or like look at the thing that's being described by the request. Something like post means like I would like to write to this thing. Something like put means like I want to update the thing. They kind of all have different meanings. For now though, get and I think get and post are really the two we're going to use today. Jenna, you said getting the site can't be reached. That's probably okay. Look at your terminal. Make sure that in your terminal you see the output. If you don't, let me know. We'll take a look. But the thing is, like, we're sort of like asking a question, and then we're never sending a response back, and that's kind of like an unusual thing. That's like, so it's a little bit of a weird demo because it's like not something you typically do, but I think it helps start to illustrate what's going on. Quota says mine says command not found. So I guess maybe okay, it looks like some folks are still having some challenges with the previous exercise. So maybe we'll go back and do a little bit more on that before I move forward. Just want to make sure everyone's kind of following along here. I guess Genevieve, Sequota, Shannon, any of you want to share your screen? I can take a look.
I will.
My computer just turned on, so I'm not caught up in any sort of way.
Ah, I mean, it looks like you got the right thing there on the right. You got all the HTTP printed out. Get / HTTP 1.1. That looks good. Good.
This my screen or somebody else's?
Oh, that was someone else's. Sequota, so in your case there, you did sudo nc-l, all one word. You want nc space -l. So
Okay.
I mentioned yesterday, and I think it bears repeating again. It's really important you get these exactly character by character correct. If you mess up a space, or like you put an extra character, or you leave one out, or you like flip characters, things won't work. So you got to make sure you get like a character by character exactly right. And it's like kind of thing you just get better at with time, like this sort of being super detail oriented.
So Ryan,
Yeah.
hi.
Hi.
So yeah, so I did mine with the space and the L and everything, and it's only asked me for a password when I did the one. It does not ask me for a password when I do a L.
Yeah, so the reason why that is sudo has a bit of a memory. So if
Oh.
you enter the command with sudo and then enter your password, it'll sort of be like authorized for, I forget how long, a few hours, something like that. So you
Oh.
can run more commands with sudo, but then if you like maybe came back this tomorrow and ran it again, it would ask you for your password again.
Got you. So I did a control C that doesn't clear it out.
So control C will terminate the command, but sort of like sudo is keeping track of that in the background. So it won't actually like reset you needing to enter your password again.
Okay.
In practice, though, it shouldn't be that big of a deal. It's still going to do the same thing. You just need to enter your password like the first time for it to have access.
Gotcha. Okay, great. So I guess I'm caught up. Thank you.
Cool. Any other questions? Okay. Going back to methods. So the method is kind of like the verb of the request. It's like what you're trying to do, and it's the first thing you're going to see. There are a few set verbs: get, post, put, patch, delete. And mostly today we're going to be dealing with get and post. I think briefly patch at one point, but you'll sort of with time get a better handle on like what each maps to as to like the kind of thing that those methods tend to do. For today and for the time being, you can just kind of think of them as opaque, like, oh, this request is a get, this request is a post. But they'll make some more semantic sense with time. The next thing, so the first word is get, post, patch, or put, all those methods. But the second word is the path. So it's space separated and is all in the first line. I'm referring over here to the right of this slide. So the way the path is structured, it's the kind of like the subject of what you're doing, or like the thing you're targeting in the request. So while the get, or while the method like get might be the verb, this is sort of like the noun or the subject. So if I did like get slash, that might mean like, give me the data located at slash. If I did like get slash foo, that could be like, give me the data located at foo. Or maybe something like post slash foo could mean like upload data or like write data to slash foo. So this protocol is kind of interesting in that it supports a lot of different flexible operations you can perform, which is kind of handy. But how do we get this path? We didn't like enter a path in our request. Where'd that come from? And the answer is the path is what's part of the URL at the top. So we're going to talk about URLs a bit later today. But this in your browser at the very top is the URL bar, and you're probably all pretty familiar with it. It's where the like identifier for what website you're going to is located. And the part I have selected right now, after the domain name at the beginning, this is the path. So what'll happen is when like the web browser makes a request, it'll take all this data here, everything I have selected, and that will be put at this location at the path spot in the request. That's where that information will be substituted in. Paths can also contain some other things at the end. The one that's we're going to talk about later as well is what's called a query string. Just know that you can add a bunch of different bits of metadata into the path. It's sort of like primarily slash separated list of like, I guess, nouns that kind of in general refer to the thing or the subject, but there's also sort of other metadata you can attach in there as well. Oh, and actually I should mention too, it's on the slide, so I should call it out. By default, so the reason why we were at slash with our requests, if you go here, you'll see get slash, is because if you don't specify a path, that's a default path slash. So that's where that is from. I guess also I'll show here, if I were to do this again, and I were to go to like local host 80, maybe like slash test 123 or something like that, I'm going to get, well, I should. Maybe I'm not. That would be exciting. Yeah, there we go. I'll get test 123 there. So maybe that was helpful. Okay, so that's a paths. Any questions before I continue? Okay. The next bit of the protocol HTTP is the version. So what's the version useful for? Well, usually in protocols, we didn't have it yesterday, but a common thing you want to do is to specify the version of the protocol that you're sending. And the reason why this is helpful is, imagine like you make a protocol, you build out this thing, you structure everything exactly how you want it to be, and then you decide later you need to add something or remove something or change something. Giving yourself a version number allows you to know, oh, am I looking at like an old version of the protocol or a newer version of the protocol? Natasha.
I'm sorry, I was asking while I was clicking the button while you were answering the question. So you are the person that controls the version that we're using. Like you name the version of what you're using, basically.
So in our case, HTTP, there's a number of versions of HTTP we could send. The first one was HTTP 1.0. After that was like 1.1, then they had version 2, and all these different versions through time. For this class, we're going to be dealing exclusively with HTTP 1.1. That's just the version of the protocol that I think is going to be the easiest to teach, and it generalizes sort of to some of the newer stuff as well. So for every request we're going to make today, and just in general in this section as well as probably the rest of Careers in Code, it's going to be an HTTP 1.1 request. So at this part of the protocol, so you've done like your method, your path, your version, the version's always going to be HTTP/1.1. So that's just how it's structured. It's just sort of like an extra couple characters you got to put in there. I did want to mention real quick, HTTP 2 is something where, like, as I've taught Careers in Code, it's become a bit more of a thing, and it's out there. It's in pretty wide use these days, but it's a lot more complicated, and everything that's in HTTP 2 also is in HTTP 1.1. It's just like some further optimizations on top of it. So I think it's a for the most part, everything you're going to learn will generalize to that if you need to pick that up at some point in the future.
Okay, thank you. I just thought it was an individualized kind of a thing where you name it every single time you use it, but name it something different, should I say, every time you use it. But thanks for clarifying.
Yeah. I'll say that sometimes if people have like different formatting of their requests, they might add another like user-generated version in there, but that's sort of more advanced, and we'll actually talk about that next week. Okay, so the next section, this is all those three things all go on the first line. So you type those three things, space separated, kind of as I illustrated here over on the right, and then you hit enter. And from after this, you've got a section that's what's called the headers. And the headers, as you might guess, is plural. It's made up of a bunch of individual headers. So like you have one header, the next header, the next header, and this is like a list of things you can specify. Every header has two parts. It has a name and a value. And the way you format it, it's kind of specific. Again, this is another one of those things where you've got to get the formatting exactly right, or else it's going to kind of complain a little bit on you. But the way it's formatted is header name, colon, space, header value, enter. Header name, colon, space, header value, enter. So I've kind of got that here. You can take a look at this example, or you can take a look at your terminal that the request you made, and you'll see some headers in there. Usually the way these headers are formatted, the header name is in what's called train case. It's kind of a goofy name for it. Like programmers have these weird names for different ways of formatting strings. And train case is one that means every word is uppercased and there's little dashes in between. And the reason why they call it train case is because it looks kind of like a bunch of like box cars that are coupled together. I don't know. I didn't come up with it. It's just what they call it. So Palash, you asked, is the request metadata the same as the web pages metadata? Can you elaborate a bit on what you mean by web pages metadata?
Right. I mean, like when you look up something on Google and there's like a page title and then the page metadata.
Ah, I see. So I think, I don't know if I can give you a straightforward answer on that. I think it's more of that it's like an intersecting Venn diagram where some things that are in a request might be exposed in that sort of context, but other things are just like, we're going to talk about the body in a second, but just like data in the body of the request. I realize it's probably not a very helpful answer, but I think that's about all I can give you.
No, that's okay. So it like some of it is the same. Like there's some overlap between the two metadatas, right?
Yeah, I think in practice, it's more just the metadata that you're looking at, like the web pages metadata. Some of that metadata actually is sourced from the request. So it might, some of it might live in the request, but just being serviced to you all in the same place.
Okay, understood. Thank you.
Yep. We're going to get a bit more into how headers are used next week. We've actually got a whole day devoted to headers, which will be exciting. But for now, really all that's important about headers is the way you can specify information about the request. Usually information about how the request is formatted or the kind of data it contains, or maybe associated metadata you want to include along with the request. A great example is like, we're going to talk about it next week, but like as a preview, this user agent header here is a way that you can specify like information about your browser. So maybe like I'm running Chrome version XYZ and I'm on Linux or I'm on a Mac or something. And that's something that like as a server, you might want to know, might sort of change the kind of data you're going to send back in your response. So the last thing to know about headers is every header, it goes like name, value, enter, name, colon, value, enter. And we have one more section after the headers. So the way that you actually like get out of the header. So if you think about it, if you just like, you're doing like new lines, you need some way you can like tell the system, okay, I'm done with the headers. I want to move on. Like I need a sort of like a terminating sequence. So the way you do that is you do 2 enters in a row. And we're going to talk about this. I got a slide on it later, but that's sort of how the section ends. It sort of has like 2 new lines in a row, and that sort of signifies, okay, we're done with the headers. And after the headers, the last section of our request is what's called the body. So there are sort of like the first line with method, path, and version, a list of headers, and then the body. The body is the last section. It's just arbitrary text data. You can put whatever data you want in here. And this is kind of the primary location that data is sent in the request. Like this is sort of like the main stuff, for lack of a better word. It is optional though. And if you look at the terminal output from the request we all just made, you'll notice there actually isn't a body in that request. And the reason why is by convention, GET requests usually don't have. So if you usually reading is like you are asking for input. I'm going to turn off my video because it looks like my internet connection might be having some issues. Sorry about that, folks. But you ask for like if read data, what you're doing is like you're asking for that data and you're expecting to get back data. There's really no need to provide in that sort of operation like data to the server to operate on. Like you're asking for that data. So that's kind of why gets typically, well, almost always do not have bodies. But just one of those things where it's just kind of how it works, and usually it's yeah, that's what it is. So you won't have a body example in your terminal, but I got another request here afterwards. It shows you an example with a body in it. So this is a post request notice. So post users HTTP 1.1. So in this case, I'm making a post request. Post is the method to /users. /users is the path. HTTP 1.1, that's the version, the HTTP version. So again, 1.1 is we're going to use everywhere. And then I have two headers here. So, and then I have content length 44. So those are the two headers I'm specifying as part of this request. And in between each one, I've got a single enter. So the first line, enter, the content type line, enter, the content length line. And then to tell it I want to start the body, I do two enters in a row. So that results in kind of like an empty line being present. So I go enter, enter, and then now I can type whatever body text I'd like. So this is a completely valid HTTP request. This is an example of something a web browser could send to ask for data. That's it. It's a more complicated protocol than we had yesterday, but it's not that much more complicated. At least I think so. We'll see. But any questions before I move forward? Okay. Now we're going to talk about the other side of it, the response. So far we've been talking about just what the client sends to the server, but not what the server sends back to the client. So we're going to do the same exercise we just did, but now we're going to actually send back a response and see what happens. And you're welcome to follow along here on your own. So we're going to do the same thing. I'm going to run sudo nc-l80. I'm going to go over to my web browser and go http:// localhost 80, and then hit enter. And if I go back to my terminal, I'm going to see the request I sent. But I'm going to take whatever in this white box. I'm going to like click on it, select it, and copy it. And I'm going to paste it into here. Now, importantly, don't try to like type line by line what's here. This is formatted in a bit weirdly because of Google Slides. So if you're going to do this, I would suggest you click on the box and then like right click and go to like select all or hit Command A or something and select it, and then copy it to your clipboard and then paste that into the terminal. So like right click and paste or do Command V or something. Just the way the formatting works, it's kind of important it be done that way. But so what I've done here is I've put some data into the terminal, and that data is sort of a response I've put together, an HTTP response. And when I put that into the terminal, that gets sent back to my web browser. And if I go back over to my web browser, you'll see it says hello world in my web browser. So what I did here is I sort of did the other half. I sent data back to the web browser, and the web browser is showing the information that I told it to show effectively. So that's that demo. Genevieve, it looks like you're running into an issue with something with command not found. So most likely, if I had to guess what you did here, is you pasted what you had here directly into your terminal. So importantly, I ran, what's it here, nc-l 80, and then I went through all the steps. And then once I went through all the steps, I then pasted it in while nc-l was running. If you went through the steps before and still had it running and still had like your web page loading, keep in mind that the way that things work, there's like timeouts involved. So if you have a TCP socket that's open and no response gets sent, it might actually close automatically after a bit. So if you're running into issues where like nc-l kind of like terminated on its own, like you're getting just your terminal back, go through the exercise one more time. Do sudo nc-l in the terminal, make the request in the web browser, and then paste it in. You just got to kind of do it in more of a quick succession for everything to work. If you think about it, normally a web browser, like this sort of communication is happening at like lightning speed. Like these are like computers talking to computers, and there isn't like a person involved who's typing it character by character. So that's why that is. So give that a shot. Oh, Tara.
I just had a question about what we entered. Like, I know we went over the HTTP, the slash, the 1.1, but why did we add in the 200 and the OK first?
Yeah, so we're going to talk about that in like 10 seconds or like
Oh,
what's on the
okay.
next slide. So right now, this is just like, I'm just sending a response back to the client just to show you what's happening at like a 10,000 foot view. But
Okay.
just like we spent a bit picking apart this request, we're going to pick apart the response.
Okay. All right. Thanks.
Yep.
I didn't know if it was like just like a template kind of thing where it's just like known that that's what's supposed to be there, or so. All right, I'll wait.
Yep, coming soon. Sequoia.
So my browser, the local host, is still saying this site cannot be reached.
Can you share your screen? Let's take a look. Okay. Can you bring your terminal over too so we can take a look at that? Excellent. Okay. So it looks like in your case, you might have done the thing where you just pasted it directly into the terminal, or maybe at your terminal scroll up a little bit or something. I can't. Oh yeah, there we go. Yeah, so it looks like you just pasted that directly into the terminal. So keep in mind what I mentioned before, how these TCP sockets can time out after a while. So if you did the demo before and got it to work, you didn't send back a response back to the client from the server. So it just like after maybe like, let's say 20 or 30 seconds, it was like, okay, I'm never going to get a response back. I'm just going to sort of like terminate. I'm just going to like hang up the phone. I'm not going to like be in communication anymore. So in order to sort of get it to work, you might have to go through the whole thing again. So you might have to run like sudo nc-l80, make the request in the web browser, and then paste the thing in the terminal, all within like roughly about like 10 seconds or something like that. Enough where like it's not going to like terminate or hang up on you. Does that make sense?
Yes. All righty.
Cool. Sweet. Can I get some thumbs up from folks if they've had success with this? Just want to make sure that generally folks are following along here. Cool. Okay. I'm seeing a collection of thumbs up, so let's take that as a good sign. Sweet.
I just had a quick question. Is there a telltale sign on how we can tell if our session has terminated in our terminal?
Yeah. So do you remember yesterday how I talked about the prompt?
Mm-hmm.
So notice how when I run this command here, my prompt goes away. I'm just like right up against the edge of the window. But then once I terminate the command, my prompt is back. So if you see the prompt at the very beginning, it means that Netcat's no longer running. If you don't see your prompt, it means that if you paste something in and Netcat's running, it's going to send it through Netcat to the client.
Okay. Thank you.
Yeah, so yep, for sure. Keeping an eye on that prompt is often helpful. Cool. So this is the response. This is an example of a response. This one's a little bit more wordy than when we pasted in, but in essence, it's got a lot of the same pieces as our request. Like you're probably seeing what look kind of like headers. You're probably, well, I've typed out response body, so I guess it's probably kind of obvious what that is. You're seeing a version, but there's a couple of new bits as well. So
hey, Ryan.
Yeah.
It looks like Sequoia has a question.
Oh, Sequoia, is your hand still raised from before, or do you have another question?
Oh, my mistake. Sorry.
Oh, no problem. So Palash, you asked, which are the client and server in this exercise? In the exercise we just did with the netcat. So the web browser is the client and netcat is the server.
Thank you.
Yep. So breaking down our response a bit here, it follows a lot of the same principles as the request. The first line has a bunch of metadata on it that's kind of space separated. Then we have the same sort of thing. We've got like a bunch of header name, header value, enter, header name, header value, enter. And these are what are called response headers. So the same idea where like you might want to send metadata information along with your request. The server might want to send metadata information along with its response. Example of like what that might be, you can see here there's this date header. Like the server might want to give you back its date or its time, just so you know like how recent the response was. Or it might want to tell you the response is in HTML, which in this one it isn't because I guess I forgot to update that. But pretend there's some HTML here. This would be like, it would tell you like, oh, okay, the response is in HTML. The response body, same kind of thing where you got like the double new line and then you have the response body afterwards. And with the response, the version actually goes to the very beginning. But there's one new part here, which is the status code. Actually, I should also mention quickly on the version that you're requesting, like if you put HTTP 1.1 in your request, you always get the same version back in the response. So you can think of that in the request, that version field as like the version you want to get back as well in the response. And it just means that like, imagine that you included in your request, like, I can only speak French. Like you wouldn't want the server to send back German. That wouldn't make sense. So the idea is you're telling the server what you can understand, so it knows what it can speak to you in. So that's kind of why that another reason why that field's there. But the new big thing is the 200 OK here, the status code and status message, and that's what we're going to talk about next year. So when you have a request, you're sort of asking a question, and you need to understand like how was the question, the response you got back, did it work successfully? Like how was the response processed? How did the question you asked go when the server was trying to figure out your answer? And the status code is a special code that kind of tells you that. And there's a series of these that are ones that you that are always specified in responses that all sort of mean standardized things. And the status code and status message kind of go together. So they also, it's just like they're always paired. So you might have something like 200 OK or 404 not found, or 400 bad requests. 404 not found actually is one that maybe you folks have heard before. That's more of one that's been more in pop culture. But Tara asked, can we go back to the last slide? Do we always have to provide the content length that includes the spaces? Good question. So in this case, so as far as content length is, at this point, we've just talked about it as like, it's just another header, but you're kind of guessing it, I think, that this might mean the length of the body, and you're right that it does. And yes, typically this content length is what you would use to indicate the number of characters that are in your response body. But that's a bit more in depth than we are at this point. But yes, that is, if you have a body, you pretty much have to provide a content length header to tell who's ever parsing that body, whether it be the client or the server, how many characters it needs to parse in that body. Did that answer your question?
Yes.
Okay.
Thank you.
For sure. So the way that these codes are structured, you've got each of these that mean different things. And there's a bunch of these. There's a big list of these, but there's a trick to help understand them. Because like there's a bunch of these numbers. They're kind of these opaque things you've got to remember. But there's a trick, and that's that if the number starts with a 2, in general, it means it went okay. So if it starts with a 2, like 200 okay, I mean, that has okay in the name, so I guess it's kind of obvious. 201 created is like another one with a 2, and that just means like they're different variants on success. If it starts with a 4, so like 400 bad request, 404 not found, 403 forbidden, things like that, those mean that there was an error processing the request, but the error was something related to the data the client sent. So it was the client's fault as to why the request was not able to be processed. So an example there might be, let's say you used the wrong method, or you tried to make a request to a path that just doesn't exist. That's what a 404 means. Or maybe you tried to request something you don't have permission to access, like it's a resource that you maybe need to be like an administrator to view, but you're not. You might get back a status code that begins with a 4. And then the last category is those that start with 5. So those mean there was an error, but it was a server's fault. So imagine like the server tried to process the request, but maybe like threw an error or something, or like try to do something like divide by 0 or something that's not allowed. That would result in some sort of 500 error. So Natasha asks, so as a 4 an error in the code itself? You mean by code like I guess define what you mean by code there, because we've used code a few times in different ways.
Well, when you're saying the client, I'm viewing it as the computer, the web page itself. So if the client has an error, then that means that there's an error in the code because it's the website, correct?
I see. Yeah, I think you got the right idea. In practice, though, I think just to change your language slightly to make it a bit more technically correct,
Yeah.
it's not that there's an error in the code, it's that it's an error in the parameters that were specified in the request. So the code that's whatever's generating that request might be generating those incorrect parameters, but the error itself is on the parameters, not on the code. That makes sense.
You will always break up every time I ask a question. I am so sorry. This is horrible. I'm just gonna have to rewatch the video for your answer. But basically, if the code error 404 is from the server, then it's something that if we developed it, we can fix that as well. Correct?
You kind of broke up on the return there too, but I think I got the gist of what you were saying. Yeah, it's
Your thing.
okay. Yeah, watch it back later, and if you have questions, reach out to me in Slack. Oh, is this more of my internet problems, or is this other folks' internet problems? Gosh.
I think
it's
it's
me-
yours. It's like I'm also not hearing you. Like, I don't know.
Okay. I wonder if there's something else I can do on my end here. I might have to spend some time during the break and try to figure it out. I'm really sorry about that, folks. I'm gonna see maybe if I can try to like go to a co-working space or tomorrow or something to make it better. Okay. Well, I'll try my best to sort of get through the rest here, and then when we take our break, I'll do some more investigation. I'm really
And Ryan,
sorry.
Shannon asked what kind of error would be would the server be at fault?
That's a 500
I guess she was asking what sort of an
to the
error
5.
it would be. Like what would go wrong?
Oh, what would go wrong? So let's say you're doing some math and your code does something like dividing by 0. Sort of not an allowable thing. Like that's an invalid situation. So that might be something where like the code just kind of explodes. Another case might be like your I don't know, like your code like throws an error. Like you have you just like throw new error or something like that, or something happens like that where like an unexpected error occurs in the code. That's typically when it'll happen. But yeah. I gotta say, you folks have quite the lively chat, have the lively conversation in the chat, and it's like quite distracting to try to talk and read it at the same time. Anyway. So I put on here a link on Wikipedia to a big list of all the codes. Yeah, wow, my internet is not doing great. So you can look here and like read about all of them if you're curious, but there's quite a long list. So you see like all these different ones, like here's our 404 that we talked about, 400 bad request. So if folks are curious, you can take a look at that. It's a good read to learn a bit more about some of these. I'll put it in the chat as well. That actually reminded me one more thing I wanted to mention. So in general, the way these codes are structured, so if you have like 200, 400, 500, they sort of start where it like starts with the correct number, but then it ends at like in the 100. That's sort of the generic version. So like 200 is just a generic okay. 400 is just a generic client error. 500 is just a generic server error. So that's often like a helpful thing to know, where you'll get back those kinds of errors with just a generic like hundreds, not like an extra number in that code. You just get back those generic values when you have an unclassifiable error, just something that's like you can't fit in like a broader category. For example, 404 not found, that's like you can't find something at a given path. But maybe there's some other 400 level like client issue that you can't classify in another like 400 code. There's no code for that specific problem. So you might just get back a generic 400 with maybe information in the body telling you exactly what was wrong. I will put that link in the Slack channel. I'll try. Oh, Doug's got it. Excellent. Cool. We are going to make some requests. So you might have seen this coming, but we are going to talk some more to our Careers of Code XYZ server from yesterday. So this is actually also, as well as listening on port 4000, listening on port 80. And we can, with Netcat, connect to this server and make HTTP requests to the server and ask it questions. So I think it might make sense. We're going a little faster than I expected. So maybe let's take our break now. Let me see if I can figure out some of my internet problems, make that a little bit better. And then when we get back, we'll make some requests. How's that sound to folks? I guess actually I should also just put out there a general, like, any questions? Corwin, it looks like you asked, have you gotten a 418? Is 418 the payment one? What is 418? Oh, that's the joke one. Yeah, 418 was a joke. Yeah. Someone put it in the code RFC, and yeah, I have not. Although I actually have read some code once that did output that as like a joke for like another, like a joke on top of a joke kind of thing. Yeah. No, I've never really gotten 418. What time is break over? Let's do like 7. I know it's a little bit longer, but just that's a nice round number. And I can give some time to look at my internet stuff. Sounds good to folks? So when we get back, we'll be making some requests to Careers in Code XYZ with Netcat. And yeah, so have a good break. 7. That was quite a bit we lost there. I'll see if I can write up some notes afterwards to try to make up for that. But including the version is like, if you don't include it, you're not technically actually like following the protocol. So you should include it. But it turns out my server doesn't actually require it. Cool. Don't get to hear your silly question. I don't think your question was silly. If I had to guess, I think someone else was probably thinking of that question and was like, oh, I'm so glad you asked it. Okay. Any questions about this most common word one that we were up to here before we digress back to the other one? Have folks had success making this request? If so, I'll go through it. I mean, okay. I'm not seeing any positive or negative reactions that much, but I am seeing folks in chat talking about future examples. So that tells me that I'm probably moving a little bit too slow, and that's fine. Cool. So let's go through this here. So this one I'm going to do connect to the server again. So it's a post request, methods post, path is text processing, most common word, version HTTP 1.1. So the headers, we've got one header we have to send, content length 44, content length 44. So header name, colon space, header value, hit enter. I'm gonna hit enter one more time to start the beginning of the body. And I'm gonna type the quick brown fox jumped over the lazy dog. Hit enter. And I get back a 200 OK, HTTP 1.1, a bunch of headers, but importantly, most common word was the. And if you look at text, those there and there twice, so that makes sense. Corwin, it says you got 0%. I'm guessing you're talking about this the next one, the sentiment one, which I guess we'll officially introduce here. We've got this sentiment example, which a bunch of folks have already started. This is kind of the next request, so give that a shot if you haven't started it already. So Corwin, you got 0%. Am I right? This is on the sentiment one that you got 0%?
Yeah, you're right. That's correct.
Okay. You want me to take a look? You want to figure out what's going on there?
I don't know if you can you, I probably should make it larger, huh?
I don't think you're sharing your screen. Oh, or maybe you are and I'm sharing my screen. There it is. Yeah.
All right.
Sorry about that.
No,
Still
you're
kind of
good.
a Zoom novice.
I thought I was just being a noob. I was like, nah.
No, I'm good.
So, I forgot oh yeah, there it is. So I just typed in the link and I didn't actually type in the value. So I realized.
Well, so what you did here actually is kind of, I think, more nuanced than maybe you realize. So look at after you did the lockbox one, it says there, you have unlocked the box. Your instructor is impressed. Oh, I think it's gonna let me draw. Oh, it's gonna let me draw. Exciting. So that response you got back there, that sort of was your last successful response. Then you notice below it, you've got here, this is your prompt. So your prompt was here, and then in your prompt, you typed this. So you were like, you ran that netcat command. So then you sort of executed another one, and you started to type out your next request. Type out post, your path. You forgot your version, but whatever. I'll move by that for a second here. But you start typing out your request. And then you type content length and hit enter. but it looks like you started to type your next request. Like you thought, oh, that failed. Okay, let me try again. So you started typing again, but notice right here, there's no prompt. So like your prompt isn't there. So you're actually typing this as your
And the
body
same.
of this request. So what it's doing is it's evaluating the sentiment of like NC careers and code.xyz or whatever. And it's like, that's not positive. It's probably quite neutral. So that's why it gave you back 0%, because you're sort of running, you did kind of an interesting situation there where you parsed it off the next command. So I guess the thing I wanted to mention here though is if you want to run your next command and you want to make sure like you're starting in a new spot, hit Control-C first. Make sure you have your prompt back before you run that command again.
Got you.
Cool.
Ryan,
Yeah.
I'm getting a 400 bad request for the sentiment one. Is that what I'm supposed to get?
Not what you're supposed to get. Let's take a look.
Okay. All right. See my screen?
I do.
Yes.
Oh, it looks like you customized your prompt too. Exciting. Okay. Yeah. So I think what might be going on there, keep in mind that after your headers, you gotta have two new lines, two enters.
After the header here. Oh, got it. Thank you.
Yep. So I don't know if anyone's curious, but is anyone wondering how the sentiment analysis thing actually works? Like how is it able to understand how like positive or negative a sentence is? Like, have you thought about that at all? Like how a computer might be able to do that?
I told that I love puppies and I got the same sentiment score as liking.
Yeah. I mean, let's just say that my sentiment analysis is not advanced, but it is workable. It produces decent results, but that is it. So like, but like if you put in "I hate puppies," you're probably not going to get you're going to get something that's negative, I would guess. I would hope. If you get something back that's positive, then it's really not great. I'm pretty sure I tested "I hate puppies" though, and that was negative. But like the way these sentiment analysis thing works is actually pretty straightforward. So imagine you had somebody like you had like someone go through a dictionary, and for every word, basically mark it as like positive, neutral, or negative. So like think of like a 1, a 0, or a -1. And then you take every word in your sentence, you split up your sentence into words, and you look up each word in that big dictionary list. And you get the score for each word. So like "I like puppies" is probably something like "I" might be neutral, "like" is probably positive, and "puppies," I think I might have picked that because I figured I might have also been positive. So what it'll do is it'll look at those words and it'll be like, oh, okay, those last two words are positive. So it'll say generally 2/3 of the words in the sentence are positive. So I'm going to give this like a 66% sentiment. And like similarly, if you had like words like a positive word, a negative word, and a neutral word, like those positive and negative words could like cancel each other out and be like neutral sentiment. It's not like the most intelligent thing out there. Like you can trick it, but like it generally works decently for like simple sentences. So that's how that particular analysis works. I didn't write it. I just downloaded something someone else had. Yeah, "I murder puppies" came out as 66% negative.
Yeah, it should be 100%, right?
I guess "I" is neutral. I bet if you did like "murder puppies" just on its own, that might be more negative. like this is a thing you could definitely game this. And once you know how it works, you're like, oh, I could like define a sentence that could produce an arbitrary score. But but like a big place this is actually used like in the world is you have a bunch of research where people are like taking people's like statements they make maybe about like how they're feeling in a like a certain for a certain day, or maybe like someone like is writing a bunch of tweets about like I don't know their life, and that's something where you want to determine like numerically, is this like a positive, a neutral, or a negative tweet, or like a negative like sentence? And this is like one potential way you could go about doing that. Obviously, if you know more about like this English language, you can write like much more intelligent things. But what's nice about this is it works for pretty much any language that's like has words as a concept that can like split up into like alphanumeric words. So you can just have a big table and you can and that's like very easy to generalize. And it's like easy to explain. Like I imagine that like generally like most folks are able to pick up kind of what I was laying down there. So yeah, I mean it's kind of neat. And like as you get further along in careers in code, just in general as a developer, like you often get a chance to sort of think about how you might implement algorithms like this and then try to write your own. And I think those are some of the most fun problems that I get to work on a day-to-day basis. When I'm given an interesting problem and it's like, you need to figure out how to calculate this thing. And I have to like just like I just have to figure it out. Like maybe I can do some research, but it's like just up to me to sort of like think through the problem. So anyway, let's go back to the presentation here. So let's go through the sentiment analysis example. It sounds like some folks have been able to run it on their own. So my method is post, text processing, sentiment, HTTP 1.1, the header of content length, 15. And I'm going to do 2 new lines. And then I like puppies. And that's what I get back. 200 okay. So that means things went successful or were successful. And that's that. So we've got one last example here. This one has 2 headers in it, and it's using a different method. So it's maybe a little more challenging, but I think generally still follows all the paradigms we talked about. So if you haven't done this one yet, I'll give you a few minutes to give it a shot. And just actually explain what this will do, just so if you know if you did it right. This endpoint, when you give it a request, the response body will print out in the response body a list of all the headers you sent in the request. So your response body should say something like, these are all the headers you sent in your request. Header A, like hello world. This is the header and this is the value. So it should like print all that out in your response. How's it going, folks? I haven't seen anyone give a thumbs up at all, so I'm guessing maybe still working on it, but any questions, anything I can help with? And Corwin, you said list of headers sent in the request. After that, you should have some lines that say like, hello world, this is a header and this is the value. So if you just see that, probably a couple of things you might have forgotten. You might have forgotten to include those headers in your request. So like that should be the beginning of it, but after that, there should be a little bit more as well.
So we should see hello world, this is a header and this is a value, or we shouldn't see that after the list of headers sent in the request.
You should.
Okay.
So what this endpoint is doing, it's a little bit confusing in hindsight, but what's doing here is you make a request to it. You give it all your information in the request, and importantly in that request, you give it a couple headers. And then that endpoint in response, the response sends you back, will print out all the headers you sent it in the request back to you. It'll sort of like tell you, like inform you what you sent it, or what you sent the server. And if you're able to get that to work, also, if you want another challenge, try to send it a few more headers. Give it like 5 or 6 headers, make sure they all come back. And they can just be arbitrary, whatever you want, doesn't really matter. Try to make them in that train case if you can, kind of like I did with this as a header.
So I must be doing something really wrong. Every time I do this, I get to the end of HTTP 1.1 and I push enter twice to put the header in.
So
And it
keep in
is
mind-
throwing me a bunch of stuff and then list of headers sent in the request and then putting me back at the beginning again.
Yeah, so keep in mind with that, when you're sending the request, you want to do a single new line, then do your headers. You want to do the double new line after your headers to put a body.
Okay.
In this case, there's no body. So you just like put in your headers, then 2 new lines, then that's just the end.
Okay.
Also, if possible, folks, just so I can kind of keep an eye on it, if you can give me like a thumbs up reaction somewhere, just if you got it, just so I kind of know how folks are doing with it, that'd be appreciated. Shannon, do you have a question? Or did you react with a different thing? Wrong emoji, okay. So Genevieve, it looks like you're written a bad request. You wanna work through it?
Sure. I must be doing the same thing over and over.
Yeah, let's take a look. Yeah. So keep in mind the format of your headers. So I think that's might be where we're getting tripped up. So remember that the way you format headers is it goes header name, colon, space, value, enter. Oh. Yeah, like that. Now if you do an enter and you put in your second header, and you hit enter. Yep, there we go.
All right, thank you.
Yeah. Well, that is the last request we have for today. So that's I guess if the folks have any other questions, I'd be more than willing to ask them or answer them.
I have a question.
Yeah.
So when I was doing this and I'm putting all the headers in, I did two where the name was I, and when I got those back, it didn't show them separately. It wasn't like I, XYZ, I do this. It just showed I and then each value next to each other. Why would it do that?
I think I might
Or why
have to
does it
see.
do that?
I think I'm gonna have to see your request. I think it's another case where I'm trying to understand what you're saying, and I'm not quite able to put it together from just you saying it.
That's fine.
Can you share? Would you be able to share your screen? Love to take a look.
Okay, I have to do it again because I closed it because.
Is it that both of the header names were the same with different values?
Yeah.
Oh.
Yes, thank you. I'm terrible at explaining
Okay.
things.
No problem.
I got it.
Yeah. So
Thank you.
typically header names are unique, but like because it's text, I mean, you could type the same header name multiple times. The particular endpoint we're requesting right now, I can just tell you that if you were to pass it multiple header names that were like the same, it would just use the last one, I believe. So like if you had like hello :world, then like hello : I don't know, like test, then the one you would get would be hello test. You wouldn't get hello world. But in general, like header names should be unique. You shouldn't specify one multiple times. And if you do, I'm not sure off the top of my head, it might actually not be allowed in the HTTP specification. Generally, though, you don't specify headers more than once. It's kind of an anti-pattern.
Thank you so much, and thank you for clarifying my question.
For sure. And thank you, Doug. Well, if we have no other questions, I think that's kind of the end of the class. I'll give you a little preview of what we're going to talk about tomorrow, just to get maybe the gears turning. But tomorrow we're going to be, so like you could think of what we did today as like long division. We're sort of doing things the long way, sort of show you what's going on behind the scenes. But I have to tell you that I've never made a request manually like this professionally. Like it just doesn't happen. Like you use more advanced tools, you use more tools that are way more powerful than just Netcat. So it's really good to sort of know what's going on behind the scenes. But from this tomorrow onwards in this section and just in general in careers and code, we're not really going to touch Netcat again. I mean, it's a good tool, but it's just not really what we need to keep moving forward. We need something that's a bit more advanced. So we're going to talk about at least we're going to start with 2, try to get to all 3 tomorrow, but we'll see how time goes. But we're going to talk about at least 2 different tools we can use to make requests, potentially 3, and where you'd use them and why they're helpful. And hopefully by the weekend, have you making some requests with some real tools to some real servers out there. So that's kind of the plan. It's exciting. It's you're going to be able to use some real developer tools and that are not just theoretical contrived things. So yeah, that's it though. If we don't have any other questions, I think that's it, and see you tomorrow. Cool. Bye, folks.